So first, well, you know me. I'm Raúl. I'm a computer engineer graduated from the University of Baja California. By day, I'm an Elixir programmer, and sometimes by night, I'm a Gleam programmer. I do come from the city of Tijuana. I like to point things on maps because that's how I learn where things are. Otherwise, I don't know. Tijuana is located on one of the corners of Mexico. So you just go to San Diego and you cross the border, you are there, you are in Tijuana. And useful data points for this, of course, it's more than 1,000 miles from Austin, Texas. And also, if you walk it out in a straight line, you can get in 20 days, nonstop. I'm also, I do work for Airline Solutions. I'm part of the America team. And I mean, we are a contracted company. So if you would like to get in contact for any kind of business or just, just to hang out, I think I have received some personal emails at this email, and it's always fun to hang out. Feel free to do so. And today I'm going to talk about specifying an Elixir system. This has been a small obsession since I started learning Elixir and learning about the many languages that exist and learning that there are many ways to validate and prove correctness of our programs. But this in particular, it's a certain obsession of me. Hopefully, I'm starting to just get over it because last talk I did about this was 70 slides. I promise today will be much shorter. So what do I mean by specification? By specification, I usually mean a document with requirements and diagrams that describe a system and how to build it. A specification can be the product on itself. This is the case, for example, for many of the web APIs. If we go to the W3C website, we might find standards for WebAssembly, WebRTC, accessibility, and many other domains. Similarly, on electronics, datasheets might fulfill this purpose, from simple sensors to processor specifications. The point is that by understanding these documents and meeting its expectations, we can approach an implementation or integration. Now, not all systems come with that level of documentation. I will dare to say that most of us are building applications for a business that does not need this kind of effort. So instead, when I do discovery by conversations, by diagrams, by maybe my writing requirements in a ticket, maybe by pair programming, Lighting tells proof that you can also write tests with LLMs. The key here is that in these businesses, usually the building happens step by step by gaining experience, understanding, and shaping the domain. What happens to all these conversations, diagrams, and tickets? Usually they are kept stored in a document somewhere on a cloud, but the nature of these documents and diagrams is not persistent. A diagram is usually, in my experience, just useful at a specific point in time, which is when you are brainstorming the ideas. Keeping documents and code in sync is hard for an evolving business. The system will grow and not necessarily in a uniform way, which brings both management and complexity challenges. So we have come up with ways to manage that complexity with abstractions, patterns, and community practices. I was going to list a couple of these, but I think a lot of these are really about limiting our ability to write Elixir. Most of us have probably heard of avoid macros, avoid reaching for the process registry. Even I had a project where we avoided reaching for OTP utilities. And these rules should be here because we want to avoid early optimization and unnecessary interaction. But by no means these guidelines do conform a specification about the system we are building. How do we know that we are implementing the right thing? One way is through tests, and probably the most important tests are the ones that directly tie to the feature you want to implement. In other words, the happy path. We cover those, and we are halfway there. And probably, if we test some of our edge cases, that should also be part of our happy path, even better. Because these are all things that we expect to happen in our system. For example, in a web server, if the request works, we send a 200. If it doesn't work, we send a 400. Surely, there are more layers and complexity than that, but you get the idea. You expect a web service to behave a certain way. Automated tests might sometimes be known as example-based verification. Tests can describe how to build state, how to execute it, and how to verify it. And I have heard that tests even get some praise as documentation for your code base. But I personally don't think that tests fulfill this role, really. Because we have all faced it, setting up complex relations in a database, setting up mocks for systems we don't control, setting up fringe scenarios with possible race conditions or environment-dependent features. All my production crashes has been about missing environment variables. It sucks, but I never learned that lesson. And all of these scenarios can make tests very convoluted and hard to follow up. So probably these are not necessarily the best starting point. So you really want to balance out how much do you delegate to automated tests? In the end, tests can serve as a form of verification that check what we want to achieve, but not much more. And another way of specifying a system is through documentation. Having healthy documentation for our modules and functions can really shine some light into the business logic of a system, into the rationale that we put it in. And probably the biggest concern here is how do we keep documentation up to date? There's not much, but one great resource in Elixir is to make use of doc tests. This is probably more common for libraries or for stateless functions in our application. But the important bits of any systems always seem to carry side effects. So it's not always possible to have doc tests for every function. And so far, testing and documenting our code can help us go very far achieving what we want. However, these techniques are still limited by what we know about our domain. What about the things we don't know, or scenarios that are complex to set up? Is there another tool at our disposal? And the answer is yes, there are many. From advanced type systems to provers to verifiers, but today I'm here to talk about a very pragmatic one, and it's runtime assertions. And for a simple example, let's say that we are implementing tic-tac-toe. I think most of us know the rules of tic-tac-toe. And what are the things that we can derive from tic-tac-toe rules? Well, for example, we know that this is a 3x3 grid. Therefore, the grid must have 9 positions. Similarly, if we sum up the pieces on the board, we know that the X and O's cannot surpass the 9 positions. And a fun property is that at any given moment, if the players 2 occupy, let's say, n numbers of positions, player 1 has to occupy either n or n plus 1. And we can know this by the turn. If the turn is odd or if the turn is fair. All of these are properties within our domain. Sometimes these properties will not exist explicitly in any document. But we might start to discover and derive them depending on our implementation. For example, this grid might be represented in different ways. It might be a grid of tuples. It might be a list of lists. It might be an initialized map with all positions already present. Or it might even be an empty map with set delimiters in other keys. The algorithm the algorithms and data structures we use will define the properties of the implementation. So how does this look? An assertion can be very simple. It can be just a helper in your code, and this helper usually consists of a predicate and a failure case. If true, perfect, we do nothing with it. If it fails, traditionally, we might raise an assertion or an exception. Sorry, we might raise an error or an exception, but failing this way with a raise is not a hard-coded rule. We might get creative on how we want to fail. The point of this check is that the assertion passes, and if not, we get notified somehow about it. Now, a couple of things to untangle here. You might notice this assertion is very similar to what we do on a test, but similar is the key word. Because your assertion sits close to your code, it's literally your code, and I think this reveals the beauty of assertions. The assertions run everywhere, on dev, on tests, and if you really want it, on production. The pro tip here, well, small sideline, you might face failing assertions at test time, and if you combine that with the stream data library on Elixir for generators, you might approach something very similar to property-based testing. So I feel like this is a very useful technique. Now you no longer have like a single test example, but you have a range of possible inputs for your tests. Also, an assertion is not meant to be used as a validator. By a validator, I mean a statement that takes in data, usually from an outside source like a database or an API, parses it so whatever comes in doesn't corrupt our program. Validations are part of our branching logic. But these are not necessarily the contract. A validation is the thing that will make the contract not to fail because of an outside source. And tangentially, something that validators and assertions benefit from is structure. For example, when we validate data, we might like to reach out for a particular library or technique. Sometimes this library might be chain sets. Sometimes the technique might be OK error tuples. Sometimes we might lean into exception structs to handle errors. The important bit here is that we find a standard for validation rather than doing them all in the single code base. Similarly, our assertions can take any shape or form, but I find it useful to define the pattern, and finding the pattern will highly depend on what you're looking for. I'm just not going to present that solution. It will depend on how you want to handle it. This is just a small example. We can start simple with a contract helper for our code, but this is not really convincing. I said earlier that the beauty of assertions is that you can run them everywhere, including production. But for that, we might want to add a couple of embellishments to this. First of all, instead of always raising the error, we could add a mechanism for different side effects, either by logging an event or emitting any other side effect. Also, if it applies to my domain, I will also get rid of predicates, and instead of returning only true and false, I will probably return tagged tuples that apply to my domain. Also, I will add support to pass in the data structures directly instead of just anonymous functions. This will help check for invariants that we know should always stand in our code base no matter what it's in our data. But I hear you, running this on production might still sound like a bad idea. Because checking complex algorithms will make this very slow. So the more advanced feature will be to add environment-dependent execution, so we can disable specific functions from running on production environments. This is where macros might come in useful, not just to disable running the code, but just to completely remove it at compile time. Now, when to keep assertions at production, I think a good heuristic for this is if all of your assertions depend on guard clauses or guard functions, for example, is map, is string, or pattern matching, guard functions are generally very well optimized and will not pose a performance issue. There are many libraries like this in the Elixir ecosystem. None check all the boxes for me. Maybe someday I will add my own into the mix. So, conclusions. There are many techniques and methods for code verification. There is no silver bullet. Assertions here are just a pragmatic way to test invariance in your logic and data structures. And places where I will avoid assertions. I will avoid it for checking types. More so now that we are getting an Elixir type system. And if we get the same benefits at compile time, the better. I will also avoid it for simple operations like arithmetic or pretty much almost any stateless function in the standard library. We trust that map, list, string modules work, so no need to check those. And also, I will not use them to check the integrity of libraries that I already trust. Places where I will add assertions. It's in complex business logic, where we do not completely trust our integrations. Things like seeing that they should work, but we are not sure, and it is not possible or just very difficult to automate its checking. I will also use it for cases of structural integrity. So if we have a data structure in our code that we think is important, like, for example, a card with prices and money, we want to map like the dependencies in that data structure so that if another function runs and changes the state of this, we know that these invariants remain stable. But most importantly, places where I will introduce assertions is places where the assertions will inform more about the domain. So that's it for me. The first picture was my favorite picture ever, and you know why now. It was taken by my daughter. This is the first picture that she takes for me, so I will forever treasure that. That's it.